Welcome to this video. The first thing we're going to do is finish up our notes on friction. It's this handout, and you're going to not the second, not the third, but the fourth page. The fourth page. Right here, this is where you put notes from the video on static friction. So here we are. Explain the similarities and differences. Go ahead and give this a shot. Take a moment and do this with your partner. Then we're going to move on to this part. Pause the video here and give this a shot as well. When you do this work, the thing to remember is that the friction force is equal to the coefficient of friction times the normal force. So if you want to impact the friction force, you have to change either mu, which is the roughness, or Fn, the normal force. The speed of the block. Does friction force depend on the speed? No, v is not anywhere in the equation. So it doesn't matter if you go any faster, the friction force is actually the same. The roughness of the surface, does that impact the friction force? Yes. You would circle this. Roughness is what we think of when we see mu. Mu is a measure of roughness. The surface area. Now you want to think that there's more friction in situation B. Isn't that what you want to think? I mean, just like you want to think that the faster you go, the less friction there is. But actually, A and B have the same friction. If it's the same block, then the normal force is unchanged. And if it's the same block and the same floor, the roughness isn't any different because you haven't changed materials. So in fact, we do not circle C. Whether you put the block on this end or on the long end, it actually feels the same friction because the roughness is the same and the normal force is the same in both cases. Finally, how hard the block and surface are pressing on each other. This picture is incorrect. This is not the correct picture for part D. If you want to make this the correct picture, then you should have both blocks horizontal, and over here on this part B, there would be like all these books and extra things on the block, causing the block to push into the floor harder. But we do know that how hard the block and surface press on each other, that's called the normal force. And the normal force is in the equation for kinetic friction. So this is one of the things that would impact the amount of friction that is produced. So you would circle D. Comparing the size of static friction with the size of kinetic friction. Here's what we're going to put down. When you push a stationary block, it takes a little more force to get the block moving than it takes to keep the block moving. You may have noticed this when you're pushing a block across the floor. You have to push harder at the beginning to get it going, and then you don't have to push as hard. The reason why this is true is because the coefficient in general, mu k, let's say mu s, is bigger than mu k for most surfaces. And as a result, the maximum static friction force is going to be bigger than the kinetic friction force for most surfaces. So to overcome static friction, you have to push harder than you must push to overcome kinetic friction. And that's all we're going to put in this section. So take a moment, solve these problems. When you get down to number 3, ignore what it says right here. It says larger vertical load increases area of contact. It's true, that's true, but we're going to ignore it because it doesn't impact the friction force. So solve these problems, take a moment. And you've already done this practice. So once you complete this video and this practice, you are ready for the next video on ramps and the attachment, the problems on ramps.